Hello and welcome everyone. In this one lecture course, yes, it is a single lecture course of about 80 minutes, we will build and test a CI/CD continuous integration and continuous deployment pipeline with GitHub Actions, Azure DevOps, and ASP.NET 8. Now, this course is actually adopted from my Udemy latest publication on the subject along with integration testing, which so over to the chapters. Now I will request you to go through the entire lecture so as not to miss out anything. So over to the course.
So this lecture is about the prerequisites, which are the setting up for the development environment for continuous integration and continuous deployment, which is this section. So let's see our slideshow. Now, welcome to this section on continuous integration and continuous deployment, also known as CI/CD with GitHub Actions and Azure Web Apps. So CI/CD is a short form of continuous integration and continuous deployment. Now we shall start from scratch and walk through setting up our development environment for CI and CD. And before we begin, we'll have to ensure that we have everything we need. Now, first prerequisite is to have a GitHub account. So if you don't have one, let's sign up for a free GitHub account at this link, official GitHub github.com. So second prerequisite is the installation of Git. Following instructions at Git. So this is the URL. Now clone the completed repository. You please visit this following link where I have kept the under my account of KRC Home integration testing to do API complete. This complete code is available at this link, and you can click the code button and copy the repository URL, which again I will show in a second. So this is the integration testing to do API complete. What I can do, because I have already logged in, so I have access to the code. So if I click this code button, then I can clone, very much copy it from here. And so next is once you have copied it from here and click the code button, which I just showed you, then you open your terminal and navigate to your preferred directory and run git clone. This is the command on your preferred directory on your Windows command prompt or terminal. PowerShell, you can go for PowerShell. Okay, and you can run git clone with the repository URL that you have already copied. Prerequisites. So we have already seen GitHub account. The second prerequisite was Git, installation of Git, and third is installing the Docker desktop. So we shall install Docker desktop, which is a crucial tool for containerizing our application. So for our to-do application, or which is a web API, we shall create a container and push it to DockerHub, a remote container registry. Container at a later stage for our CI stage of our CI/CD pipeline using GitHub Actions workflow. So this is the Docker's official website, which is www.docker.com/product/Docker desktop, and you can download the Docker desktop for your operating system. And here are the prerequisites for installing Docker desktop. To install Docker desktop on your machine, there are some system requirements you should be aware of, and these requirements can be found from the Docker official site, which is for Windows operating system, it is at this site, and for Mac, it's at this URL, and for Windows, Mac, and then finally Linux, it is on this URL. All right. So after having complied with all the system requirements and having successfully installed the Docker desktop, you have to verify, you should verify Docker disk has installed correctly or not by opening a terminal again, Windows command prompt or PowerShell, and type docker dash version or hyphen version, whatever way you call it, to ensure Docker is installed correctly. Okay. Now, this is the fourth prerequisite, and the last prerequisite is creating an Azure web app. Now, we'll set up an Azure web app where we'll deploy our application. So, first step is to create an Azure account. So, if you don't have one, sign up for a free Azure account at azure.com. This is Microsoft Cloud, if you've heard about it. Okay. So, now creating an Azure web app. So, you'll have to log into the Azure portal from here, azure.com. Once you've signed in or created a registration free of cost initially, you could log into the Azure portal and click create a resource, and then web and web app. And then in the configuration of the web app, you choose a unique app name, subscription, resource group, and region. And then click next to configure other settings as needed. And then review your configuration and then click create to create your web app. It's all very clearly demonstrated, and just follow the on-screen wizard and on-screen instructions to be able to easily create your web app once you are successfully logged into your Azure portal. Now finally, once created, you can access your web app from the Azure portal. Welcome back, everyone. In this lecture, we are going to delve into a pivotal aspect of a modern software development, that is GitHub Actions. So as we have seen, we have been building our To-Do API solution. We have reached a point where we want to automate various development processes, from continuous integration to continuous deployment. So GitHub Actions is the tool that can make this automation a reality. So that is the importance of GitHub Actions. It allows us to automate workflows directly within our GitHub repository. So let's get started with the GitHub Actions. Now to access GitHub Actions, we'll go to the Actions tab with our GitHub repository. So just a quick look at the Actions, how it looks. So here is my repository on GitHub on test-driven development demo. So if you click on this Actions tab, so it will have all the workflows. So you can create a new workflow, which we'll do in subsequently. So one of the primary use cases for GitHub Actions is continuous integration, or CI. We can configure actions to run our tests automatically whenever we push new code. So beyond CI, GitHub Actions can handle continuous deployment, or CD, as well. We can set up actions to deploy our application to platforms like Azure Web Apps, as we'll exploring later. Welcome to this lecture on containerization with Docker. So in this session, we'll learn how to containerize the To-Do API application using Docker. And by the end of this lecture, you will understand the benefits of containerization and be able to create a Docker image and container for your application. So what is Docker? Docker is a platform for developing, shipping, and running applications in containers. Containers are lightweight, isolated environments that package applications and their dependencies together. And what are the benefits of containerization? So why use Docker for your applications? First point in favor of containerization is portability, and the containers run consistently across different environments. And isolation is another property that is one of the benefits, and which the applications and dependencies are isolated, reducing conflicts. And it's got an easy scaling up and down as needed. And the application as well as dependencies are containerized basically, and you don't need to create all the dependencies, restore all the dependencies at another person's computer or in the production environment. So, and for version control, these images can be versioned and tracked as well. Now let's see about the Docker architecture. So Docker consists of the Docker engine, which includes the Docker daemon and Docker client. And images are used to create containers. So you can understand, you can just imagine images are just like classes in C#, and types and objects made out of the classes are containers. So images just can be synonymized with types or classes, whereas containers with the objects created out of those types or classes. And DockerHub is a registry for storing and sharing container images, just as GitHub is for code repositories. Now, adding Docker support with Visual Studio. So we shall leverage the power of Visual Studio to simplify the process of containerizing our application. And Visual Studio makes it incredibly easy to add Docker support to our project. We'll see soon in this lecture. So it automates the process by generating a Docker file suited to our application's needs. Now let's go for adding a Docker support with Visual Studio. So what we are waiting for? Let's go deep into adding the Docker support with Visual Studio. So let's open our project in Visual Studio. So I've got my To-Do API solution, which is ready for getting the Docker support. What I will do is I will add to this project, our main project, To-Do API, add Docker support. Now, although the default operating system is Windows, now I will switch it to Linux, because what in my experience I found that if you target Windows operating system, then when you push it in a forthcoming lecture to the DockerHub for creating the continuous integration pipeline, it will come up with a container operations are only supported on Linux kernel. So that's why I target the operating system as Linux, and this will be the targeted operating system on the DockerHub. So let us click. Now it has given me a Docker file straight out of the box within the blink of an eye. So that's great with the Visual Studio, right? So that's what is being told in this slide. So right click on the project in the Solution Explorer and select Add Docker Support. Visual Studio will prompt you to select the target operating system and framework, which we have already seen, and we have chosen the option that best match our project's requirements. Now this Docker file, this is the automation for building a Docker image and then running the Docker image to create a Docker container. Now this Docker file, we'll soon see, it contains instructions on how to build a Docker image for our application. Now this Docker file is at the root of our project directory. As we can see over here, this Docker file is created. So this is the Docker file for this project. It's on the root directory. So we won't go deep into these commands as yet as a review. So let's take a look. So open the Docker file on your project directory, which I had opened earlier, and you will notice that it includes the instructions for the base image, which I have already shown, and environment setup and copying your application files to the image. Now at this juncture, I would like to tell you that in the next lecture, I will be dedicating completely on reviewing the Docker file and understanding each and every line of it from a developer and as well as a student point of view. So till that time, we'll move ahead with the Docker commands next. And what are the Docker commands? Now we'll be building a Docker image. Okay, so this is the command Docker build. So this is the tag name flag, my to do API, the latest is the tag. This is sort of version. Okay, so we'll see that in a second. So Docker build builds an image and T flag specifies the image tag, which is like a version. Okay, and my to do API latest is the image name with the tag. And this dot at the end of this tag indicates the current directory where the Docker file is located. So let's flip over to Visual Studio and run this command. So what I will need to do is tools and command line. Either you could open the developer command prompt or developer PowerShell. Either of the two are powerful command prompts actually. So let me open developer PowerShell. Okay, so it is residing on my to-do API completed directory. Is automatically it has selected this path, and our Docker file is also sitting on this directory. Okay, so let's give this the command. So I have opened them side by side just to see our commands and to issue the commands. Okay, so let's give it Docker build and then this dot. Okay, I hope you are able to see it. Let me try to enlarge this screen, zoom it up a little bit if it can be zoomed. It's too much zoomed. So let's get it back. Okay, I think it should be all right. Okay, let's run this command and see what happens. So you can see immediately these steps are following the instructions of the Docker file. It is following the Docker file instructions and creating an image. So if everything is fine, it should be able to run all the steps, all the 17 steps successfully. Is step 11 out of 17. First time it takes a little bit of time. So there are 2 warnings but no errors. So that's, we are lucky. So everything is done. What next? All right. So it has successfully been able to create or build the Docker image. So you can see, just quick check over this. You can see all these steps. Step 1 out of 17 from this as base. It is work directory, app, using cache, using this num id, exposing 80, using cache, and it is running those steps one by one. All right, so let's move over to the next part of the slide. So next is running a Docker container. So what is the command? Docker run D, that is in detached mode. It is running in the background. And port -p is this flag p is port 5017. This is the on the host computer, on my computer here, and this is the port on the container. This is the port on the container, this is the on the host machine, and this should be the name of the container, which is my to-do API container, and this is the image to be used, that is my to-do API lattice. So let us quickly review. Docker run starts the container, D runs the container in the background, and this maps port 5017 on your host to port 80 in the container. And this name, this dash name, my to do API container, gives the container a name, and my to do API latest is the image to use. So what we are waiting for, let's run these commands like we did to build the image. All right, so you can see, I'll again condense it so that we can just copy what we have written over here, so that you can see that I'm copying exactly as I have written on this slideshow. So Docker run Now this port 5017 will most certainly differ on your machine. Okay, so I will tell you from where you can find it if you are unsure of it in a moment. This is dash name. So my to do API. You can give it any name. Okay. To do API dash container or hyphen container, and I will use this image that I have created, my to do. If I am writing the correct name of my image, it will run. Otherwise, it will give me some error. So you can also verify the image that you have created. Latest. Okay. So that is the docker run command. So just a quick check, docker run -d -p 5017 is mapped to 80. Name my to do API container, my to do API latest. This is the most important, the image name, or you can even use the image tag, which I will show you again. So let's enter it. So this is all done. This container is already created. Okay. So what you can do, you can just run a command like this, which is not here in this slideshow, but docker docker ps process status. So you can see this is the image. So this is a container ID, which is 264.264 E5, the same container ID that has been created, and we have used the image my to do API latest. Okay, and this is the command, and created 28 seconds ago, just a little bit ago. So you are able to now build an image and run a container. So in the next lecture, we will be pushing the container to the DockerHub registry. Hello everyone. In this lecture, we are going to go for the container integration in DockerHub for the to-do API container that we have created in the previous lecture. So as an introduction to DockerHub integration, DockerHub is a cloud-based registry for Docker images. And it's a great way to share and distribute our containers. It serves as a reliable source for pulling images when deploying applications. And here are the commands to push Docker images to DockerHub. First, we'll have to log into the DockerHub. That is the first step. And log into DockerHub before we can push an image to DockerHub. We shall have to make sure we are logged in with the DockerHub credential, which is Docker login. And this command will prompt us to enter username and password on DockerHub if it is not there already on as a cache. Okay, so let's switch over to our Visual Studio and click on Tools, and then Developer Command Prompt, Developer PowerShell. So I've opened the Developer PowerShell. So let's input Docker login. So authenticating with existing credentials. So it could find my existing credentials. If it couldn't, then it would have prompted me for username and password. Anyway, fine. So let's get back to the slideshow again. Now let's see the command to push the Docker image to the DockerHub. So we have to first tag our local image. So tag your local Docker image with your DockerHub username and the repository name, which is Docker tag local image, your username / repository name :tag. Whereas the local image is the name of your local Docker image that we used in the previous lecture, and username is the DockerHub username, because you need to put in the DockerHub to log in, username and the password. And the repository name is the name of your repository on DockerHub. So let's run this Docker tag. So let me switch over to Visual Studio and to the command prompt, and it's better that I get it side by side, put it side by side, and bring the command prompt over here so that we can see what we are doing. Docker tag. So this Docker tag, local image. So my local image was my to-do API latest. My to-do hyphen API and then colon, and the tag was latest. And then my username is on the DockerHub is KRC home 6645, and let me put the repository name as my to do, again hyphen API hyphen DockerHub, and then colon, the tag is again latest. Let's enter this. Okay, so done. That means it is all tagged. So let's go to the next slide. Now commands to push the Docker images to DockerHub. Now we push the tagged image to DockerHub. So that is Docker push your username / repository name colon tag. So where you know everything, your Docker username and repository name is again the one that we use for tagging, and the tag is the version or tag for your image. And let's do this last step, Docker push. I'll bring it down. That's fine. So just let me expand it a little bit so that I have more space on the right hand side. So Docker push. Your username is again my KRC home 6645 / so this I have already written, your username / repository name colon tag. So this was my to do API dash DockerHub colon latest. So here I have to write this part. Hyphen API hyphen DockerHub colon latest. So I put the DockerHub at the end just to emphasize that we are on the DockerHub. This is being pushed on the DockerHub. Alright, so let's, the push refers to the repository, and now it is all preparing and waiting to push everything. Okay, so we'll revisit once it is done. Once it is done pushing to the remote DockerHub repository. So it's all done. Okay, so let us check this repository, my to do API dash DockerHub colon latest. So let's go to the Internet Explorer and DockerHub. So let's refresh it. A few seconds ago, my to do API DockerHub. Alright, so I pushed this image a little earlier, just a few seconds earlier. So in this lecture, now this is the end of this lecture, and in this lecture we have seen how to integrate your local image to the remote DockerHub repository so that you can pull it at a later stage or anybody can use it if it is a public DockerHub repository, and we'll be using this image to our CI and CD pipeline to build our continuous integration and continuous deployment pipeline. So, creating the continuous integration pipeline for the To-Do API application. So, in this lecture, we shall explore the key concepts and steps involved in setting up the continuous integration for the To-Do API project. So, CI or continuous integration is a crucial practice in modern software development that helps ensure the quality and reliability of our code base. And as a CI, in short, for continuous integration overview, CI is a development practice where code changes are automatically built, tested, and validated every time they are pushed to a shared repository. The main goal of CI are to catch and address integration issues early and ensure that the code base is always in a working state. And to implement CI or continuous integration for our To-Do API project, we will be using GitHub Actions. As we have seen in an earlier lecture, GitHub Actions is a powerful automation tool that allows us to define custom workflows for our projects. Like we have seen in a lecture about website checker and how the GitHub Actions workflow is built, and it's automated and it builds the application and restores the dependencies. So we'll extend it further. So GitHub Actions seamlessly integrates with our GitHub repository, making it an ideal choice for automating CI or continuous integration, which we have already seen. Now for setting up the GitHub Actions, first we need to set up the GitHub Actions for our project. And how do we do it? So GitHub has fortunately made this process straightforward and seamless. So by simply clicking on the Actions tab within our repository and selecting New Workflow, GitHub opens the Choose a Workflow page. We are going to demonstrate everything in a bit. So on the continuous integration block, clicking on Configure creates a basic workflow YAML file. Okay, so let's do it in practice. So here is my integration testing To-Do API complete private repository on GitHub. Now, if you click on Actions, if I click on a new workflow, I already have a workflow. I wanted to demonstrate how I set up a new workflow. Okay, so my previous workflow, these are all workflows, but it will not interfere if I create a new workflow. All right, so they will work independent of each other. So create a new workflow, and it gives me a Choose a Workflow tab. So here you have got this continuous integration. Now let's go back to our slideshow and see what it says. So going back to our slideshow, once we click on the configure, it creates a basic workflow YAML file within a GitHub workflow folder, which is auto-generated, and we need to customize and commit this file for triggering the CI. So let's get back to GitHub again. So if I click on configure over here, as you have just read, it will automatically create this .github/workflows folder with a .net.yaml file. Now I already have a previous workflow that created .net.yaml, so I need to change the name of the file to something like .net1.yaml and then click on commit changes, and this will ask me for an extended description, so I will just write something like this, guys, and then commit the changes directly to the master branch rather than going for the second option, which is to create a new branch for this commit and start a pull request. And I want to keep it simple, so I go for the first option. So commit changes. If everything is fine, it will create .net1.yaml .NET1.yaml. So if you go for the code, you will find that GitHub workflow has got one .NET.yaml file and one .NET1.yaml file. Now the next step is to customize my default file. So as you can see on the slideshow, while GitHub Actions provides a default workflow, we'll edit and customize the .yaml file generated as default. And this file will define the specific steps we want our CI pipeline to perform. Now, one key customization will involve storing and accessing secrets to and from the GitHub repository settings, which I am going to show you now. And let's discuss further before coming back to the GitHub repository settings. These secrets allow us to securely retrieve the to-do API Docker image from DockerHub during the workflow run. Alright, so let's get back to our actions. So I have got this Docker password and Docker username, action secrets and variables, which I have already set earlier. So this is my DockerHub password and DockerHub username. So how did I come from? From where did I come? So I had clicked settings, actions, settings and security, secrets and variables, and then secrets and variables, actions. And then I had created, with clicking this new repository secret button, I could create any number of secrets or variables. So there are no repository variables, but repository secrets are there. I can change it, I can delete it, but I will go with the Docker password and Docker username. And these two will be retrieving, it will be used in customizing our self-generated .NET1.yaml file we have just seen a while back, and we'll customize it so that it could log in with this username and password on the DockerHub and fetch the image to run the to-do API solution in the background, which is important for running the CI process. So let's now go back to our, before the build and test step, let's go back to our customization step. So I have got my code, and then within the .NET1.yaml file, which is the new workflow, I need to change this file. So I'll click on the edit mode and I will make some changes and commit the code. Now the changes are on my clipboard, so I will just click on edit. It's already on the edit mode, so I will just highlight everything and paste the clipboard code. Okay, so you can see there's a lot here changed. So API, there is an image which is my KRC home 6645/my-to-do API DockerHub, which is the image we pushed for the DockerHub integration. If you look back into your one of the previous lecture where we did the DockerHub integration, but I will quickly show you. It is here. So I have put this two pages side by side. This is a DockerHub website, and you can see this is the image over here, KRC home 6645/my-to-do -API DockerHub, which is this, the one that we had actually pushed a few lectures back. All right. Now let's now commit these changes and update .NET1.yaml. So you can leave it blank or you can give it an extended description. So it's always a good idea to give it an extended description for a later documentation purpose, For CI test, okay, customize the new workflow for CI test and click on commit change, and again I am going to commit directly to the master branch. So now everything is okay. So now it has already committed the changes to the .NET1 YAML file. And now if we click on actions, you will see these two commits, the same commit basically, and one is working on one workflow and another is working on the other workflow, but both have the same commit message. A single commit actually triggers or activates both the workflows, all right? And one is actually your .NET.yml and the other is .NET1.yml, but I've given a same commit message because it's a single commit. It is update .NET1.yml message is being shown. Now let's wait to see. Oh, now both the YAMLs, both the workflows have run successfully, and that's great. So let's see one of them first. So this one, it's all done. It's setup job, initialize container, run action, log into DockerHub, setup .NET, build, test, etc., etc. So now in the test, you can see that it has successfully run 4 tests, passed the 4 tests for the unit tests project, and for the other projects also, it has actually run 13 tests. Now similarly, if you look at the other workflow, so here, if we had seen this one here, let's see this one, because both have actually run. So both will show exactly the same result of the build. So it has completed a job very successfully. Now let's switch over to seeing actual continuous integration pipeline in action. Finally, our CI pipeline is now ready for executing the tests, and these tests will include unit tests in a separate project, which we have already seen that unit tests have already passed. And by adding, now the next step, we will add and remove some tests in this project, and we shall trigger CI workflow to run. All right, so next we'll do that. So at the moment I have got these 4 unit tests, okay, 1, 2, and 3 and 4. So let's comment out one of them, okay, or just both of the last 2 tests. Name value is not null and name value is empty. So, and then this thing, just save it and then test it again, run all tests. So I'll have to first, before testing, I'll have to actually comment them, yeah, to make sense. All right, so now let's run all the tests. Now only 15 tests have been discovered, so 15 of them passed. Okay, now I have to commit the code. So you can see here I have actually highlighted, I am on the git changes page, and I've got one change over here, and that is in the unit test 1. It is modified, so give it a message. Comment out means it is already removed, okay, and commit all. So commit created locally, and then pull it, and push the changes, successfully push to origin master, okay, and then synchronize. So you can see successfully synchronized incoming and outgoing commits. So let's now go back to our GitHub repository and inspect our code. Okay, so let's go to the previous page, code page. Okay, so unit tests removed 2 numbers. So it is already given the message. Okay, so now let's go for the action. So now I have opened up the actions tab, and you can see this, the 2 workflows with the same commit. Unit tests remove 2 numbers that we have committed from the local repository. They have both run successfully. So this build is ticked all right. So everything has passed. All the setups, initializing containers run action checkouts, login to DockerHub, setup.net, and build, test, etc., restoring dependencies. Everything has done to our full satisfaction. It is completely perfectly all right. So it has run 2 tests from the unit test project, and it has also run the rest of the tests from the integration and the other project which had all the integration tests. So you can see the results, 13 tests. Now if you go back to the action tab again and look at the other build, this is also passed. It's exactly the same thing. So basically I have been able to demonstrate successfully that continuous integration pipeline is in place and very much working, and you can test it simply by adding some code and checking it into the repository, GitHub repository, or committing and pushing the changes, and it will take over the build process on the GitHub Actions workflow, and it will test, it will do all the things that you have already dictated in the Actions workflow, which are here. This is again .NET.yaml and .NET1.yaml. Both are using the same. This is using one Docker image, to-do API Docker image, .NET.yaml, and this is using another Docker image, my to-do API DockerHub. So I have actually tested with this YAML first before recording for the training purposes, and I've used another image. This image we have already integrated into the DockerHub after creating it locally. Alright, so hopefully this has been a good lesson for all of our learners, and you have learned a bit about how to set up CI pipeline and how to test it. Hello and welcome all. In this lecture, we will be deploying the To-Do API application with Azure Web App. Now, as a brief overview, we'll learn how to automate the deployment process of our .NET Core application using GitHub Actions and Azure Web App. But there are some prerequisites. So I'll show you what Azure account I have just in a minute. So I've got this Microsoft Azure account, and I would advise you to create a free Azure trial unless you have already a live account. So you can check with this try free account, create a free account for yourself, start free by clicking the start free button. Okay, but I've got this pay as you go, so you can check for all these popular services free for 12 months and 55 other services free. But that's not the point of this lecture. So let's move over to the next part of the slideshow. So next is we have to create a resource plan. So how do I create a resource plan? Let's go over back to our Microsoft Azure page. So I'll create a resource. So I'll click on create a resource button, and I will create a web app. Okay, because this is all about hosting it on a web app. Okay, so on this create web app, you can see that I have got a existing Azure subscription on this list, drop down list. So that's the only one I have got, and I need to create a new resource group. So I don't have any existing resource groups. So what I do, I will create a new resource group. So the name is let us create a new resource group. Resources, something to point out that it is this is my initials, deployment resources -krc. Okay, let's click on OK, So it's all created for me. Now let's go for the web app name. So I can choose any name that I want, but let's do a meaningful name. To do API. To do API is not available, so let's do it like this. Just do a bit of a manipulation about the name. To do API, it's still not available. To do API is still not okay. Let's give it a name. To do web API. It looks like it is available. So when I am able to do it, the deployment, the website will be hosted at, like, to do hyphen web API dot Azure websites.net. Okay, and publish the code, because I'm not publishing the Docker container but the code, and it is not a static web app. And runtime stack, let's see what is going to be there. Runtime stack is .NET 7. Okay, standard term support. Operating system is Linux, Windows, and region is the nearest region to you, because I am actually situated, located in New Zealand, which is in the Pacific. So let's go for the nearest, could be any of these: Australia Southeast, East, or Australia Central, maybe Australia Southeast. Okay, so Windows plan, all right. New ASP deployment resources. Okay, it has already, the plan was already with me. This plan was not deleted earlier. So ASP deployment resources KRC. Okay, and I don't want to create a new one, so this is the one existing with me. And let's explore the pricing plan. Here you have to be very careful, and standard S1 with 1.75 GB memory and 1V virtual CPU or whatever it is. So let's explore the pricing plan, because I want to go for the cheapest pricing, or if possible free. So let's shared, let's go for the free F1, and others have got different prices, so I'll go for free. So I will not go for all of the explanations, they are meaningless for our context, but click on select. Okay, shared infrastructure and zone redundancy. Next is deployment. This is my account, it's already loaded. GitHub Actions setting enable. It was by default, it was disabled, but I have to enable it because that is the main thing, GitHub Actions, through which I wish this continuous deployment. Okay, so you can change the account over there, and organization, select organization, say KRC home, it was there, and repository, it is loading. Okay, so let's go for my repository, which is, you can see I've got a complete drop down list of all my repositories. So integration testing to do API complete, that's the one we are going to work on. Branch is master, so there is no other branch but the master. So workflow configuration, file with GitHub Actions workflow configuration. So let's go for previewing the file. So this is my GitHub workflow action, which I need to actually make. File path is GitHub workflows to do application production.yaml. Okay, so that's already created for me. Just close this. Then next tab is networking. So enable network injection off. Next is monitoring. So application insights, region Yes, okay, that's fine. And then tags. Tags are name value pairs that enable you to categorize resources and view consolidated billing by applying this same tag to multiple resources and resource groups. Note that if you create tags and then change resource setting or other, your tags will automatically be updated. So I choose not to give any tag, and let's see, review and create. Okay, free SKU, estimated price is free. Okay, and then so now my to-do web API is deployed. So here are all the summary. So I can stop the application or browse the application, and I've got this subscription. All the details are already filled with the resource group, location, subscription ID, and the name to do web API, code, .NET version 7 is the runtime stack, default domain is this. Okay, and hosting is already there. Now if I let's try to visit it. Default domain is this one. Let's see what happens at the moment. So wow, it's already deployed. You can see https todo web api.azurewebsites.net/api/todo items. So here it's on the secure https protocol, and it is you can think this as the replacing the localhost :port number and /api/todo items, which I have already shown. And these three items on the web API are coming through the to-do API application with the initial data seeding. So now this thing is ready. Deployment is ready, but I need to connect it to the continuous to make it a continuous deployment pipeline. I need to do something else on top of that. So let's review our slideshow where we are and how much we have already gone through. So I have already created the resource plan on the Azure portal, and we have created a new web app. In fact, we have created a new web app, and in the incidents we have created a new resource plan. Okay, so in the get publish profile, we'll have to open our GitHub repository and go to the settings and secret. We have to create a secret for this. Okay, so let's go to our GitHub action. Next we click on settings, and then secrets and variables, actions, and new repository secret. Okay, so it was there, so it is now updated 24 minutes ago. So this Azure app service publish profile, I didn't need to create it. It is automatically created while I published this application, deployed this application. It's automatically created for me. All right, that's great, isn't it? So it is all seamlessly being managed. So it is Azure app service _ publish profile. This is a number. Okay, so most of the stuff is done for me. Now it is already commit master to do web API.yaml. Okay, so I think this is the one. Okay, it's automatically set up like this. It has got the publish profile, everything that is secrets. It is automatically getting it from the secrets. Okay, so let's go for the action. It seems everything is getting completed to our satisfaction. So this is all completed. So let's see the summary. If we click on the summary or just go back. So 1 minute 4 seconds it took, but it has done the trick. It is already deployed. Continuous deployment pipeline is already built. Here you can see that it is with the build, it is going for the deployment. So let's wait for some more time. So .NET publish, set up job, run actions, checkout, build with .NET publish, upload artifact for deployment job, post run actions. So it is actually getting completed. First it was built, and then now it is going for the deployment, to completion of the deployment pipeline. So you can see that everything is complete. So now deployment is starting. So build is all complete. Let's go for the setup job. Deploy to Azure Web App. And this is the next step. So we'll come back once it is completed. So I can show you that the deployment is also completed successfully. In the build, it had done all of these steps, and in the deployment, it has done all the rest of the steps. Set up job, download artifact from build job, deploy to Azure Web App, and complete the job. So now we are ready to test the continuous deployment cycle. So that I can cover in the next lecture. Welcome all. In this lecture, we will understand the Azure deployment workflow. If you look into your just previous lecture when we set up the deployment pipeline with Azure, it generated a action workflow automatically, and it is here. Now this is GitHub/workflows master to do web API.yml. So this was done when the project was published or deployed by Azure Web App on Microsoft Azure. Now what I intend to do is to explain this code, as it is of importance that you understand. So what I have done is I have actually written the code in 3 different sections. First is the event trigger. So I have reproduced that code from that file. If you look into this file again, which is here. So this part is on the event trigger part, and there will be 2 more slides on build and deploy. So again, going back to the code. So what happens? So I intend to explain each of these branches. So in event trigger, the workflow triggers on push event. So on push event to the master branch, and also allows manual triggering with workflow dispatch. So what is manual triggering with workflow dispatch? So workflow dispatch is an event in GitHub Actions that allows you to manually trigger a workflow run. So when you include workflow dispatch in your workflow file, GitHub provides a button in the GitHub Actions tab, allowing you to trigger the workflow run explicitly. The next section is the build. So build job, build. So this uses actions /checkout at version 2. It checks out your repository to the runner. And then .NET setup. It sets up the .NET Core. And then .NET build. Okay. So it builds the .NET Core app in release configuration. Configuration is release. And .NET publish. So it publishes the app to a specific directory. And then upload artifact. It uploads the artifacts published app, which are the published app for later use in the deployment job. Finally, the deploy job. in the deploy job, there is download artifact. So downloads the published app produced by the build job. So it Azure /web apps deploy version 2 uses the Azure web app deploy action to deploy the app to Azure. And with the app name is here, it is to do web API, slot name is production, and publish profile, it authenticates with Azure using a publish profile stored in the GitHub secrets. Okay. And package is the path to app files. So this workflow automates the build and deployment processes, ensuring that your app is automatically deployed to Azure web app when changes are pushed to the master branch. It's a great setup for achieving continuous deployment to Azure. Okay. Hello everyone. Welcome back to our final lecture, which is testing the complete CI/CD pipeline. Now, it is where we'll put our entire journey into perspective. From setting up our development environment to creating a fully automated CI/CD pipeline, we have come a long way. So today we will demonstrate the power of our pipeline by initiating deployments and testing the integrity of our application without a graphical user interface. So our To-Do API is a web API application designed for simplicity and efficiency. Unlike applications with graphical interfaces, ours communicates with clients through endpoints. Today, we will focus on the significance of deployment testing, a critical step in our CI/CD pipeline. Now, let's jump into a hands-on demonstration. I'm going to deliberately tweak our unit tests. Why? Because we want to see the CI/CD pipeline in action. By modifying the unit tests, we are signaling to GitHub Actions that changes have been made to our code base. This triggers the automated pipeline. So what we are waiting for? Let's jump right into the action. So this is the Azure portal. Logged on to my Microsoft Azure portal, and this is where I can browse or stop my application, which is this one, to do -webapi.azurewebsites.net, which is this one. Now let's try something, tweak our unit test. So what I will do is I will bring up the To-Do API solution. Okay, so in the solution explorer, I have got this project To-Do API.unittests. So this is the project. So at the moment you can see there are 1, 2, 3 and 4 tests. So let me just remove by commenting one of the tests. Let me remove just one test. Comment out. So essentially now there are 16 tests. So you can see 16 tests all have passed. All right. Now there is another change that I can do. This will be the continuous integration part. Now this will actually prove the continuous integration pipeline in action by running the tests and just showing how many tests are there and how many have passed. So it will be 3. But before we go on to our GitHub Actions workflow and test this build process, we'll go for the Azure for the deployment part as well. We need to test the deployment. So because our unit tests are now tweaked and our CI/CD pipeline has kicked in, which we'll see in a minute, running tests and deploying our application. But what's unique about our deployment today? We are not just deploying code changes. We are pushing new data to Azure. How? By making changes to our DB initializer class, which is where it is. Now I've got 4 to-do items, so I will add just one more. So copy from here, new to-do item. You can have anything that you pledge to yourself that you used to do. simply get Azure certified. Okay, and save the changes, and now push the changes. Okay, so there are two changes. One is on the DB initializer class and another is on the unit test class, and I have not even bothered to build it because it will be all built on the GitHub Actions workflow when it is kicked in. So let's give it a message. So this is the master branch, only branch I have got, remotes origin master. So enter a message. Testing the CI/CD pipeline, commit all. So this commit number created locally and then synchronize, pull and then push. All right, now let's see the fun. So let's again go back to revisit our GitHub workflow. So this is the workflow. Now see, there are 43 workflow runs, out of which the latest are testing the CI/CD pipeline, okay, and testing the CI/CD pipeline 3 times, build and deploy, commit. This one is for build. Let us see if it shows the test. So let's see, it's going to build and test. So it shows all of these actions have been done, completed to the best ability of it, and all completely corrected. All tests have done. Clean up Docker login credentials, post setup.net, post on actions, stop containers, and complete job. So our thing of interest is that let us see the test run. Okay. So I've already switched over to my GitHub Actions and I'm going to witness our workflow in real time. So every step contributes to the end-to-end testing and deployment. Okay, so let's see. Our thing was main interest was that we now have 3 tests and all tests have passed. So we have actually now integrated the tests successfully. From 4 tests we have now 3 tests and all have passed. Okay, so next step is checking the Azure web app. So the previous steps we've already done, GitHub Actions workflow and deploying the new data to the Azure. And now let's check the Azure web app. So heading straight back to my portal, I already have this running and I have rendered this website, and let's refresh it. So you can see that get Azure certified, the last entry that we made on the DB initializer class is also there. Now, before I move on to the next part of this lecture, let me tweak another change to my web application, that is the web API. So DB initializer class again. So let me get rid of the last 2 items and push the changes. So why I'm doing this is because I just wish to show you the action workflow for build and deploy in live. So just push syncing the changes. All right, so it's going to, I'm sure it has kicked in the workflow. So deployment testing. All right, so this is build and deploy. So it is getting built in real time, starting the job, run actions, set up .NET Core, build with .NET. All the steps are going to be done one after the other. Build with .NET. Now we have come to the build with .NET. Takes a wee bit of time, but it actually takes place in its due course. So you can see run .NET build, configuration release. The next step will be .NET publish. So timing is important. You can see that it started just 2 minutes 7 seconds ago. So we are just watching it live. So this is all live action. So now it is fast. Once the build with .NET, it took a long time. The .NET publishing is also done. Now going to the next step of uploading artifact for deployment job. And then it will be post on actions at checkout version 2. And then it will be all deployment. And we'll come back once it is finished to view the deployment in action. Okay, so build is already almost over. Oh yeah, it is all right. Now it is getting deployed. You can see starting the job. Job is waiting for a hosted runner to come online. Setting up the job. So complete job name, deploy. So all of these steps are nicely getting executed automatically. It's all the automation that's very important. So we have been able to successfully check the GitHub Actions workflow in real time. And finally, it will be deploying to the Azure web app, and then it will be ready to be rendered live on the website. Package deployment using zip deploy initiated. Again, you can see that it is all started 1 minute 2 seconds ago, still deploying to Azure web app. So completed, everything is finished. Now let's visit our website again and then refresh it. There were earlier 5 items. I would expect it to have only 3 because 2 of the items we have already removed. It's just a refreshing. Okay, so you have got 1, 2, 3. So this time it is not written in a nice manner, but we get the message. So we have just witnessed that our To-Do API is live, and any changes that we made to the data is being reflected here. It's a testament to the effectiveness of our CI/CD pipeline. The power of automation ensures that our application is always up to date without any manual intervention. So as a conclusion, as we wrap up this course, we reflect on the journey by thinking that we started with a blank canvas and now we have a robust CI/CD pipeline. From our local development to automated testing and deployment, and the skills that we have acquired are invaluable. Now, please feel free to explore further, customize your workflows, and apply these principles to your projects. The world of continuous integration and deployment is vast, and you are now well equipped to navigate it. So, before we conclude, I would like to open the door or the floor to any questions that you might have, whether it is about the course content, CI/CD pipelines, or anything else related. I am here to help. Your understanding is crucial to your success, so don't hesitate to ask anything. Thank you very much for joining me in this journey through this course.